Hi, what I'd like to do today is I would like to just, make a very interesting WebAssign problem, a rather complex WebAssign problem, and just show you all the things you have to do for it. So this is a pretty complicated one. Most of them probably aren't going to be this complicated if you make them, but this is probably what you want to use. So I'm just going to go through a bunch of different things that you could do to make a WebAssign problem while making one that I'm making for a class. So I went here to questions create, and that brought me to the question editor. You'll notice that there are things that we need here. This is like the third time already that I've tried this, so my computer remembers the title. You need a title for one of these things. And I need an airplane cruising. Okay. You need a mode. There are a bunch of modes. Normally, if you're doing physics problems like me, you'll do a numerical problem like this. We'll end up doing the multi-mode here and choose a bunch of these things, but we'll get to that a little bit later. Because what I'm going to do is I'm going to do multiple choice, then I'm going to do another multiple choice question. The first one will be sort of to analyze the problem. The second one will be to choose a free body diagram, which basically describes the forces on the system, and that'll be from a large matrix. Then I'm going to come down here and do a little bit of symbolic work. So I'll do algebraic and symbolic, and the reason why I'm going to do algebraic is because the symbolic editor doesn't let you put little arrows on top of things. So it'll pull up the phys pad. So if it pulls up the phys pad, then your students will see the same thing. And we'll go through what the phys pad does a little bit later. But it won't grade things. It won't be able to grade something that has an arrow over it for a vector. So I'll do one thing in algebraic, and then I'll do another one in symbolic, because the symbolic's easier to work with. And then after doing those two, the phys pad things, then I'll do a numerical question. And that'll be a bunch of stuff, right? The numerical question is just to personalize it for the student, that sort of thing. Make them feel special, all right? One thing we're going to use a lot is this test preview thing. So first, let me get some stuff in there so that we can do the test preview. I got some files, so I'll use up here in Page Tools my files. I've got some pictures. And so I'll look in my picture directory, see which ones I want. Well, I want airplane at cruising altitude, which is just the level plane. I've only got one. It's pointing to the left. And let's see. Then I have this free body diagram matrix that's pointing to the left, and I hope these are correct. So I've got both of those, so I press go up here, and bang, I've got these things in here. So if I hit test preview, now it gives me this preview thing, and it's warming up. And you see there, we have a nice airplane and a free body diagram matrix, which looks large, but probably it's mostly looking large. I hope it's mostly looking large because I've put the zoom up to 150% so you can actually see some of these things. I hope you can see them, right? But if you can't see them, I can't really make them very much bigger because then you won't be able to see a full word. So let's see. I think the first thing here is if I look at this, or not my files, if I look at the test preview, this airplane was sitting there on the right side or on the left side of the screen, not looking very good. So I'm going to move it over to the right. Now I don't know much about how to do this. I haven't been able to figure out the user image tags. There might be a tag in here that I could use, or not a tag, but a user image is a tag. So there might be something in that which would just let me send it off to the right-hand side. But what I do know how to do is use HTML, and basically you're going to do a bunch of HTML programming, because this is what you get. You get like 1997 grade HTML in your little editor here. So I'm going to put a table and shove that to the right-hand side like I would have done when doing web design in 1997 and selling my joke site for $10 billion at the IPO or whatever it is. So I put this stuff in here, press test preview, and hopefully that airplane has gone all the way over here to the right-hand side. So it's way over there. And you say, well, why do you need to do that? Well, I didn't need to do that, but it's a little more aesthetically pleasing since it's moving to the left to have it on the right. So, you might want to think about those things. You don't have to. So let's see what we can do. So we've got that guy there, and at this point I'm probably ready to actually write down what I want the problem to say. Now, I really want this to be pretty bare bones. I'm really going to focus on what's the physics, what's the free body diagram, stuff like that. I've got other problems that are a little more complicated. So I just want to type in what's going on. So an airplane cruises at a constant speed, which I think probably is the same thing, cruising and moving at the constant speed. So let's change that to flies. Yeah. At a constant speed at its cruising altitude. Okay, so that should say that it's at a constant speed and it's at the same height. So if it stays at the same height and it's going at a constant speed, that means that this is a Newton's first law problem, right? So I've got that. I've got that in there. It's got a propeller. So let's just say its propeller produces a thrust. I don't know if that's correct. I'm going to call it a thrust that keeps it moving, and its wings provide lift to keep it aloft. So hopefully that's enough information to tell the students what's actually going on so that they can answer the stuff later on. I don't think I need anything more here. Right, so I think the students, I think the students can figure out the rest for that. So again, this is real live HTML, so just hitting enter doesn't work, right? You have to have these line feeds BRs, and for some reason I did one capitalized and one lowercase. Let's see. In the following problem, you will analyze the situation in terms of Newton's laws and the free body diagram. Boudet, yeah, free Boudet diagram, body diagram. Dell is active today. Let's see. So there you go. I put some text in there. Since I aligned this over on the right, the text is going to do something like this. And the same would happen if I aligned it to the left, then the text would go on the other side. But if I had just put the image in there, the text would go under the image. So that's part of the reason for that table. So you see I've got 2 bits here. It doesn't look like quite enough. Later on, maybe I'll figure out a way to improve that. But right now, we just want the bare bones stuff. We don't want to force too much in there. Let's just cut this out and show you that if I don't put those line feeds in myself, I don't get that space. See, it's now all one paragraph. Right, so now I've got one paragraph all by itself, which is which is fine. But if you set something out like that, then it's going to actually look a little bit nicer for the students, so that they can process the information a little bit better. So we've got that stuff going on there. Next, so I'm going to start the problem with part A. Let's see. To start the problem, you should ask yourself, you being the student, what should you ask yourself? How Newton's laws come into the situation and why? Okay. The table below, so I'm going to make a table below as a list of 5 reasons that you might choose either Newton's first law, and I'm using the superscript to put the ST up high, or Newton's second law, and as columns for each law. Choose the button. It's a oh, I forget the name of them. I knew them earlier. Radio something or other. The radio box that best represents the law and the reason for using it in this problem. The correct law, so there's only one law that works, and represents the correct law and the best reason for using it in this problem. Actually, they're going to be mutually exclusive reasons. Okay, so there we go. Now we need a table. This table is going to have our multiple choice problem in it. Okay, so we're just going to do our multiple choice problem in this table. And I'm going to do it in the old boring way, which is I'm going to do each row separately. And we don't have to worry about line feeds again. Line feeds only come about because of these BR breaks. I know that if you use some of these other form-based things, it'll interpret a line feed or a return, like this return in this table here, as a line feed in your typing somewhere. So that does really bad things to tables. But not for this one. So you can just use standard sort of HTML techniques. So let's see. Representation \law. So what I'm doing is I'm just making the, first line of the table, the column labels. I'll underline those. That's what the U is for. TD for the next row or next column, right? TR is for rows, TD is for columns. Obviously, it's not TC. I have no idea why. And we're underlining these, and this is, well, let's just call it N1. And \underline \TD, TD U, Don't use UL for underline because that's another thing. And that's for a list. That's an unordered list. /tr. At the back we'll have a table again. I probably should have done that before. I'm going to come up here and give the abbreviations. Okay, so I don't do a lot of HTML programming anymore, but back when I did it all the time, I'd always say, okay, I want my row. There I do. So I put both the opening and the closing tags together, go into the middle and start typing again. So now I want a column, td \td, right? And probably I should just copy and paste that. So I need 1, 2, 3 of these things. So I've got 1, 2, 3 here, and that's for that row. That's going to be for A, B, C, D, E. So I'm going to have 5 reasons, and I'm going to have 3 columns for each reason. The first is the reason. So A, what is the first reason? The airplane is not moving relative to your reference frame. Hate to use something like a reference frame in there, but because it's technical, but this is technical jargon for physics, so we may as well use it. And I don't know why Dell is trying to be so helpful today. I mean, obviously, I've never even seen that one before. I don't know where it came from. I even did this video for 35 minutes before I decided, there was too much that was wrong with it, and redid it, right? So it didn't do that. So actually, the last couple of times I tried to record it, it was nice. It was perfect. It didn't throw any weird things on my screen, but tonight it wants to throw weird things on my screen. Oh, so the airplane is not moving relative to your reference frame. Another thing that we'd want to do is the airplane is moving at a constant speed relative to your reference frame. And then you may have noticed while I was jabbering about other things that I put this tag in here. This is a WebAssign tag. Less than _ greater than. That says that this is a place where WebAssign is seeking input. And if you want to turn this into a column, if you want to turn this thing into a table of little clicky buttons that will mean different things, then this is how you're going to do it, right? You're telling it, this is where I want my little clicky button. Almost. For a normal multiple choice question, the WebAssign will take this first clicky button and turn it into the multiple choice question. We're going to do something a little bit different, because if you do that, then it not only won't put the little buttons inside of the table like I want it to, it will randomize the order. Right, and I want the order to go along with the descriptions, right? Although you can have as your answers sentences, so that's not really a horrible thing, but it is still my preference to put this in a way that makes sense to me. Right? Doesn't mean it'll make sense to the students, but it makes sense to me, partially because I'm the one who's programming it. So if it doesn't make sense to me, even more things are going to be wrong with it. And now I have to finish up the different rationales, but it is not changing its speed. And then we put little clicky boxes in there. And then we need the last rationale E. The airplane is, I forgot is's, forgot both of those is both turning and changing speed the same. Okay, so these are all standard, so they might be a little bit different. Now I've already got another one of these working out, so I programmed one of these previously just to go through the entire process. So you know, I want to do things a little bit with those. I will probably make 5 of each one of these. So what this laws 1 here means is that it's in a pool. It's in a pool so that I can have several of these different problems that are more or less the same problem, but with different answers, so students can have their own personalized problems. Probably should have more, especially since spring's going to be my heavy semester for this class, but that'll come in the future. Just to get this working the way I want it to work, I'm probably going to need 5 of these for 10 different questions, maybe 12 or 15. That'll be plenty of work, right? And if it seems like it's doing the right job, you know, which it may not do the job that I want it to do. I've got a specific plan for making such a complicated problem. There's a reason for it. If it doesn't do anything in that zone, then, you know, maybe I shouldn't worry about making even more of these problems. Now, it's possible, you know, a lot of people say, well, you have to have enough of these things or so forth and so on, and if you don't, you're not going to see anything. I don't really believe in that, right? You know, if you're actually doing something, then you should see some response. Might not be linear, probably it will be, but might not be linear. So maybe, you know, if I have 5 questions for 100 students, you know, they'll trade answers and stuff like that, and it won't be good enough, and I probably need to have 15 or 20 so that people don't know somebody else with the same problem and stuff like that. But we'll worry about that later. First we want to get through this, see if this kind of training actually helps at the end of the day when I look at their force concept inventory scores, FCI scores. Okay, so let's just see if this works pretty well. But does the thing I think it should be doing before I do the other stuff. Okay, so that's looking all right. One thing is I'd rather have this centered, and 2, these little things, these tags here are better turned into little radio buttons. So I think the first thing we want to do is center the table, because that's easy. So we come up here and say align equals center. Okay, and then we come down here to our answer, and we do our answer. Answers, for some reason, it's still EQN, right? So it's EQN as far as when you're doing a numerical problem, means equation. It's a third WebAssign tag. So so far we've seen, there are more that'll show up, but so far we've seen this funny looking thing, this user image tag, which we only get, well, I guess we could type this ourselves if we know the numbers of all our images. And then we have our equation tag. Now for this we need some variables. Ordered equals some number. Let's look at this. So let's figure out which one of these should be correct. Okay, so I've done the bad thing, and now it's, see the little clicky buttons here, but it doesn't have any answers, right? So the question is what is the airplane doing, right? And the airplane's flying at a constant speed. Okay, well, moving at a constant speed at its cruising altitude. Actually, I'm not saying whether or not it's turning, so I should probably add that up there. So something like moving in a, it flies in a straight line at a constant speed, or at a constant speed in a straight line at its cruising altitude, or something like that. So it's going to be this. That's either going to be n1 or n2. Now, if there's no acceleration, then it's n1. If you're flying at a constant speed in your reference frame, then it's going to be n1. Actually, a constant velocity. So I better change b to constant velocity. Okay, so velocity. But that was number 3. Remember that. And as long as I'm here, path to its destination. This is a reason why students can't understand anything you write as far as questions are concerned. And it's not just my questions, it's questions from Survey, it's questions from Friedman and Walker and Young and stuff like that. You know, you go in and you try to specify the problem so that they don't make any assumptions that are wrong. And in the end, you know, now all of a sudden they've got so many little details that they can't keep track of the problems. So you can't really win. Okay, so we said that the correct answer was 3, so we say ordered equals 3. This says we're going to put the answers in order, and it's the third answer that's correct. Okay. So now this would just put all the answers, I think. We can test that. Let's go ahead and test that. This would just put all of the answers in one of those boxes, right? So we want to put them in multiple boxes. I think if I just do this, it's all in one box. So let's put these in order the way I want them to be. So that's 1A, right? So if we look at this here, right, I typed this one in first. That's 1, 2, 3, right? 4, 5, 6, 7, 8, 9, 10. This is 1A, 2A, 1B, 2B. So 1A, then you press enter, 2A, 1B, 2B, 1C, 2C, 1D, 2D, 1E, 2E. And so those are all the answers. Now, I think what's going to happen is when I hit test preview, it's going to reload this. It's going to give me the whole list in that one box. So yeah, that's not what we want, right? We want this 1B here. That's the right answer. We want it to be right here. So what we're going to do instead is we're going to come back up here, and we're going to do $set underscore each underscore position equal 1 semicolon. And now, if we test that guy, what do we have? We have 1A, 2A, 1B, 2B, 1C, 2C, 1D, 2D, 1E, 2E. You won't have this little X here, so it'll look a little bit better in the real, in the real thing, but this is close enough. So this is the right answer here. Now you will notice that if if you're a physics guy, that each one of these letters A, B, C, D, E has only one answer for N1 and N2, right? It's either N1 or it's N2. It's not none of these could ever have the second thing moving, right? So this thing's changing its speed. That means there's an acceleration, which means it cannot be N1. It has to be N2, right? And there is absolutely no situation where that will be Newton's first law. And it turns out that that means that there are only 5 of these that are true, and the other 5 are wrong. So that, or not true, but can be correct. Only one of them will be correct, only 5 can be correct, and the other 5 could never be correct. And really, that's good, right? So I'm going to give them actually 6 chances to do this. That's why I'm giving them an extra dose of different things. But on top of that, you get this 1C here. You get this entire array here. If they can figure out, even if they can even get to the point where they figure out that only 5 of these are available in the first place, and they can always just go through click test, or click submit, click submit, click submit, click submit, click submit, and be guaranteed correct answer. I think they would be, if they really knew that, I think they would be better off than a rather disturbing percentage of students who get B's in a class. All right, so you think they'd know better, but somehow they're able to do the problems without actually understanding those things. So hopefully we can get people to understand that just by doing this. Hopefully they'll come away with that at the end. That's part of the reason for this. All right, so that is the first part, right there. So we're good to go with all this. And I can hit save here, right? That'll say I'm done with this part, and now I don't have to worry about it until the next part, right? So that's half an hour to do that, partially because I was just talking to you, right? And partially because it takes a long time to do the first one of these. But like I said, these are all going to be the same. So I'm actually going to use this as a template for several other things, right? For several other questions. And because of that, they'll go a lot faster. The other ones will go a lot faster. The first one actually took me all day. Now I've already done this, right? So I've got the example sitting on the other screen. And so this should actually go a lot faster than creating it the first time. But once I've got it done, it goes pretty fast. Numerical problems don't actually take that much time. So that's probably what you do the most if you're doing physics. But they do take some time, right? So it's like any sort of programming thing. It's amazing how little you get for your time sometimes. And then all of a sudden everything comes together. It's amazing how much you got for such a little amount of time. But that's only at the end you say, wow, I did all that. So this is a good place for me to stop and take a little break, and I'll come back a little bit later, most likely tomorrow. My screencast-o-matic should not be up here. That's the screencast software that I'm using. Shouldn't have learned about other things that I do like that. Oh well. Okay, so I'm going to let this go for a little while. I'll come back, and then we'll get to actually looking at those free body diagrams. All right, now I'm back, and let's see. We've gone through. I probably have to check it out since it's been something like 12 hours. But I think we've just been through the first part, and I'm going to have to sign back in. Fortunately, when I do this, signing back in this window is perfectly fine, and everything's okay. So I've gone through this table here, which has this answer matrix. Next, I want to do these free body diagrams. I'll probably have to fix this up. I don't know why. This one didn't scale particularly well. The other ones had scaled perfectly fine. This one did not. So let's see what we can do with this. All right, so we want to go to our next part, which is part B, which is to find the free body diagram. So using your result, or analysis, let's call it, analysis from part A, determine which free body diagram best depicts the situation. I mean, that's really all you need. You don't need a lot. I've already described the situation. It's right up there at the top, so they don't need to be reminded of it. The forces. Okay, so kind of remind them that what we care about are forces here. And then we need a new list. Now I just want to have a list A through whatever it is, L. So that should be 12 of these things, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is just to tell this that there's a new this section is just to say there's a new multiple choice question. Actually, this is something for the multi-mode. Sometimes this gets a little bit confused, even though I put the EQN in there, right? And this is again going to be ordered. Let's see, $ ordered equals, we don't remember because we haven't figured it out yet, which is the correct free body diagram. So let me see which is the correct free body diagram. Oh, come on. It's faster last time. Oh, did I leave a tag open and it doesn't show me my free body diagram? I left the tag open. So let's try it again and see what my free body diagram looks like. Is it hidden at the end of the line? Okay, I'm sorry, this is a new one. I'll just put the 12 things in there. Let me see. So let's do the set each position so that they end up in a line equals 1 semicolon stuff and not sir. And we want A through L. H, I, J, K, L. All right, so maybe it doesn't know what the section is, so let me put the multi-mode option in there. So what we're going to have here is 2 multiple choice questions in a row. So I'll put those in there for the multi-mode. We don't really need the multi-mode for that. The one after that will be algebraic. Then we'll have symbolic. And after that we'll have numerical. Probably I shouldn't put all of these in at once because it might not like it. Let's see. Perfectly fine with it. Okay, so now what we need is this airplane moving at a constant speed at a constant altitude, right? So we're going to have 0 as the net force, so it's one of these 6, A, E, I, C, G, K. And this did not scale very well. It's going to have lift, it's going to have thrust, it's going to have drag from the air resistance, and it's going to have a weight coming down. So the correct answer is G. So then you have to go through A, B, C, D, E, F, G. So G is 7. So we want ordered equals 7 here. And that should get us a thing with the correct answer. right? So this G is going to be the correct answer here. So that's good. We've got that all figured out. Somewhere in the middle there is a correct answer. So then, what do we need to do? I think what we need to do this is I'd like to have a little list here of all the forces on the left. And I'd like to have that list of forces on the left so that when the students are looking at this, they know what each one of these letters means. And hopefully I can make the letters nicer at some point. It's not too important, but it would be better. Okay, so I'm going to put the table in there. It's only going to have one row. The first row is going to be that interaction list. And the second row is going to, or column, excuse me, the second column is going to be that image. And for my interaction list, I'm going to make another table. I'm going to put a table in a table because, you know, I'm like that. All right, and each row of this table is going to have first a symbol, and then a force. Okay, and if I did an underline before, I'll do an underline again. \tr. Maybe I should give this a title. And I just said it was an interaction list. Let's make the width of this first column 150. Hopefully that's sufficient. I don't think it is, but we don't want it too big because we don't want to push the forces too far to the right. Okay, so what's our first force? Well, we have a small f for friction. That could be the first force. Actually, it probably isn't. Let's do this in alphabetical order. So drag, or D, is air resistance. Students love to use FNet. I didn't put FNet here, but students just love to put the frictional force on the free body, or the net force on the free body diagram. So put that symbol in there even though we don't use it here. Hopefully in the future we'll have some other ones that do have them. Actually, I do have some other ones already that has something like that in there. Let's see. We need the thrust from the propeller, the weight going down, the normal force from the ground. Okay. You say, well, why do we need that? It's one of the symbols that's in there, right? And it's there to catch the students, because students really love to put normal forces in, even when there are no normal forces. So we want to sort of confront them with the fact that, you know, you want to confront them with the fact that the normal force isn't there. There is no normal force because there's no object that the plane is sitting on. Because they want to put that normal force in anyway. They always do. Lift from the wings. Okay, so friction and drag. So friction and normal force are the fake ones, and we have 4 real ones. Drag, lift, thrust. Drag, lift, thrust. And weight. We need the weight. Okay, and so the weight of this thing is W. All right, and there it goes. That's in there now. All right, so hopefully that'll give me an interaction list. Did I? No, I didn't undo the table. So backslash table. Hopefully that will give me what I'm looking for, which is an interaction list on the left-hand side. Excuse me, these letters are big because I've, blown this up to 150%. I may or may not have told you that. So now I have my interaction list over there, and then I have all my interactions over here. This is telling me this guy's too big. That's okay, we have to fix him anyhow. So then we have our symbols and our forces, so that our students can look at this key, so that they can figure out what's supposed to be going on. So that's perfectly fine. We're good with that. Let's see. Now we're done with the multiple choice parts. Now we'll get to the good part, where we're actually doing something really, really advanced. So C, we want to write the equations of motion for the airplane using your free body diagram. From part B. First use, okay, so that's probably fine to start with, actually. So I write the equations of motion for the airplane in vector form. So this is actually really easy, except we're going to have to put a note in there for the students. It's going to look like that. The left-hand side is equal to the right-hand side. Now, I give them some instruction about how to do that. The left-hand side is just the forces. So let's say the impinged forces will go on the left-hand side of the equation, and the net force, if any, goes on the right-hand side. There's some more instructions I'm going to have to do because there's some problems with this algebraic mode that we're going into right here. So this is a new section. Section just means that it's going to file through. Now remember, we did the multi-mode. There was multiple choice, multiple choice. Now we're going to have A, which is the analytic or algebraic, excuse me, mode, which will bring up the phys pad. So, yeah, there's another copy of this down in the bottom, by the way. So now we have to just go through and look at this. Now this is complicated. It's the new one section. Let's see. You have the big EQN again that says tells WebAssign this is something we want to grade. Now we have to use something called a cast grader, which I'm not sure what it is, but it basically is saying that what we want to do is we want to use Mathematica to do the grading. We want a pad. We're going to choose our pad, and our pad is physics. the phys pad. And after we do that, we say what variables are we looking for. We want T, L, D, and W. Those are the 4 variables on the free body diagram that we chose, right? So we look at this and we go to G. We don't need to open it up again. Go to G, we have T, the thrust, the lift, the drag, and the weight. So we want to add those together, right, to get our left-hand side. So those are the variables. Now we have to tell the WebAssign what the form of that's going to be. Now what we want to do is we want to force the students to use the vector symbols. So this is how you do it. You write vector, square brackets, whatever it is that you're doing, L plus vector D plus vector W. Okay, and then we have things that WebAssign told me to do when I asked them how to do this. I don't understand what they are yet, so hopefully I'll figure that out eventually. Release, hold. Okay. More of these square brackets. I think it's square brackets. Rationalize. Hold. Oh, wonderful. Key minus response. Good. One, 2, 3, 4, double equals 0. Okay, so hopefully that will give me a phys pad that will work when I do the thing. So when I come down here, see it hasn't figured this out, and it has text form. Okay. Let's see where I've screwed up. I may not have screwed up, but I think I have screwed up. So let's see, $pad phys. Okay, did I miss something? Semicolon. Okay, so CAS greater Mathematica, okay. Curly brackets tab. Full simplify. Release. Oh no, it's release hold. No, release hold, okay. Rationalize. Hold. Square brackets key minus response. Did I do that right? LDW, vector. Oh, I had a curly bracket there. So that screwed me up. Hopefully that'll fix that up and it'll understand the LaTeX. Okay, there you go. So it says D plus L plus T plus W. But if I use this, I go D plus L plus T plus W, and I come down to my submit for testing, it should tell me I'm wrong. Hopefully it tells me I'm wrong. It does, good. But now if I come over here, click on vectors, and turn each one of these into a vector, nope, that guy didn't work. All right. and submit for testing. It should say the world is good. Right? And it did. It said that was fine. All right, so what I'm going to do, I'm going to change the order just to show you that they don't have to do it in order. Right? Submit for testing. And it says it's okay. Good. I'll take one out to show you that it definitely notices when one is missing. And there you go. It's not happy about that one. So we've got that figured out. That's good. So we can just add those up. I'm only going to do this for the first time I let them see this. For the first phase. I don't do it in the later ones. I just want them to get used to seeing vectors as equations and stuff like that, and to understand how this thing, right, turns into the component equations that they'll look at later, because I think a lot of times they don't really understand all that. So that's the first one. Okay, now we need the right-hand side. Actually, the right-hand side for this part is simple because we don't have, because it's actually it's probably the same thing. So why don't I just copy it? So this is fairly simple. There's only one issue, which is I want this to be a vector 0, and it can't do vector 0. Okay, so instead of what I'm going to do is I'm going to use capital O. So I'll do test preview. Right, and it says d plus L plus T plus W is equal to the 0 vector, which is good. That's what we want. So because we have this sort of net force equals 0 over there. So you've got all that in there. That's good. Let's see what we can do. I think what we have to do is we have to say something about this O without giving away the fact that it's O. So we're going to have to add that, plus I'll add some instructions up here about how to type if it's not O, right? So let's see. Where did I put this stuff down here? So ER. On the right-hand side, to indicate the derivative, use the form above. If indicate the derivative for the acceleration, use the form above. If the net force is 0, use the 0 vector, or write the 0 vector using a capital O as the vector. I'm going to do another WebAssign specific thing. I'm going to do something called O arrow. This S notation pulls out all of WebAssign's. WebAssign has a bunch of symbols that it has available for you to use. This will choose an O with a capital O with an arrow over it, assuming WebAssign has a capital O with an arrow in it over it, which it may or may not have. I believe it does. Right, so if we come down here, see, it does have the that form. So we're okay. Clickety click, click, click. All right, but now I have to put that form up here, and in this particular case, the only reason why we're doing this is to not give away the fact that the answer is the 0 vector, right? But, you know, that's fine because we want to redo this over and over and over again, so we'll choose what we think is best. Vectors and derivatives. Okay. BR table. BR TD. Okay, first I'll do something. I'll just write a vector, right? So I'll say S capital V arrow, vero. So that's going to be V arrow is equal to V sub X symbol X hat, which is going to give us the X hat direction, plus V sub Y slash sub S Y hat. That'll tell the students that they should be using components later on, how to use the components, what I want them to see. And I want a slight indent, which is why I'm using a table. All right, and then we need a backslash table. All right, and then over here we want to do the derivative. So let's use R. I think it's double dot, not D dot. I think it's D dot in LaTeX. Equals. Now we have to do WaTeX so that we can do M S dot those things frac. So we want to use the fraction thing from LaTeX, because WaTeX is the WebAssign WA Tech version that doesn't have all the things you want it to have. Okay, so you have to play around with it a little bit. All right, so I got through that, and then we'll do an S dot, or that should be an S mid dot. And what I use R. Okay, backslash WaTeX. Okay, let's see. This should be mid dot. Okay, and let's see what I have. Did it actually write the thing I wanted to write? And yes, it did. Doesn't look great. Let's see. What can I do to improve that? Oh, I put sub instead of soup for that guy. Let me check something out. Okay, let me see. This should be soup instead of sub. And I don't like the way those brackets look, so let me see if I can make I can make this work. Maybe I think this would let me get the larger brackets over the entire fraction. And it does, good. So that's going well, but that does mean I have to raise that square a little bit more. So rather than using this, let's see if I can just use the LaTeX power. And no. Sometimes that works, sometimes that doesn't. Curly braces, maybe? If this doesn't work, I'm just going to live with it, because I can't think of anything else that might work. Oh, it did work. Okay, good. So I have r double dot is equal to m dot. This is basically the form they need to type the derivative into when I do the other thing. So to do the mass times the square of the derivative, I got all sorts of different things I could use, but I want something that works for both the symbolic and the algebraic, and just do that every time. Different ways to think about these things. So that'll be sufficient if they actually needed it, but they don't, because it's a completely other kind of problem. All right, so got the stuff we need for them there. So let's do 2, write the equations of motion, the component equations of motion. In the x and or the y and z directions. And so now we've got a new section because we're using the what are we using? We're using the symbolic mode instead of the algebraic mode, mostly because the symbolic mode is easier, right? Look at all this stuff we have for this algebraic mode. So we go to section, do the same thing. Let's see, y component space blank equals blank. Same format that I want them to use otherwise. And then dr, and was a key off, z component. Okay, so now we need to write one equation for each one of these 4 blanks, right? We used one algebraic equation for each one of these. Now we want one symbolic for each one of those. So we do equation $pad equals phys. So we don't need the cascrator for this. We just need the $phys, and we do basically the same thing, right? We're going what's in the up direction, well, or in the horizontal direction. We have the propeller, which has a thrust, and we have the air resistance or drag there. So what we have is thrust is in the negative direction, so drag minus thrust, right? So thrust is going to the left-hand direction, so that's negative. So drag minus thrust is what we want. And that's it. And then equation $pad equals phys 0. That's all we need for that one is 0. All right, and then we do the same thing again for the z direction. For the z direction, we need a new line. We have lift and weight. Lift is going up, weight is going down. And so let's see what we've got. Test it out. Ooh, this is a Phys 0. I don't like Phys 0. Did I do anything weird here? Oh. This thing's supposed to have... I'm putting this empty character here because I have no idea what it does. Okay, so you know, I can find the examples where it's used. They always have the little basically empty character at the end. I have no idea what it does. Nobody tells me anything. But because I have no idea what it does, I have to do it just like a cargo cult, right? So easy enough here. D minus t, minus t is equal to 0. Right? Submit for testing. And it's happy, right? So that's what we want to do, right? Everything's hunky-dory. So these are the components down here. These are the vectors up here. Again, vectors I only do the first time these things are introduced. After that, we just go straight to the components from the free body diagram. Because the unfortunate trick to physics is, even though you keep telling people you're using vectors, you find ways around having to use them. That leads to all sorts of conceptual problems in the end, but it makes people get better grades on the papers. Let's see. Now we need a part D. So we can say Cessna, oops. Oh, here's the bad part, because I should, somewhere I do, have reasonable numbers for all these things, but that doesn't mean I have them right now. Cessna, let's say 172. Now let's give it a letter H. They've got lots of different 172s. In fact, that's something we could randomize right there. They don't make much of a difference for this problem. I'm sure they have lots of very important differences if you're actually applying the plane for this problem. They're all close enough to the same. Has a weight of let's say 1, or now we use little eqn, and this is going to tell us that we're going to use a little Perl line to give us a random number. Okay, and so we want a weight $W is equal to whatever our minimum is. Let's say, I feel this is small, but I can't prove it. 5,000 newtons plus the integer part times the integer part of a random number, rand, times 50. Times 100. This is how, when I was a kid, I learned how to program. Say loaded. Anyways, this is how I learned to program an AppleSoft Basic when I wanted a random number. So now I'm going to have between 5,000 and 10,000. So actually I'll put a 51 here. In groups of 100, is that right? 51, 5100, yeah. So in groups of 100. So there's not going to be 7523 newtons, right? And we put the newtons on the end. So that gives me a random weight. And lift to drag ratio of these things are reasonably high. Equation WL, lift to drag ratio, LDR, that'll screw me up later on because it has too many letters, of, let's see, 9 plus the integer value, or integer part of the random number 21 divided by 10, so that'll be between 9 and 11, right? 9 plus a number between 0 and 2. Did I get all of my? I got all of my parentheses, so that's just a number. While flying horizontally at altitude. Let's say the propeller produces a thrust of little eqn, $t. Now we do the same thing. We want to figure out what that should be. Let's say it's 2,000 newtons plus the integer part of the random number 51 times 10. So it should go to 2,500 here, I'm hoping. Newtons. So 2,000 to 2,500. And then we need to ask a question. What is the the only thing we can ask is the drag. So we already know what the weight is going to be, right? We know the weight, which means we know what the lift is. So what we want to do is we want to find what is the drag on this thing. Actually, we know the drag too. Okay, so let's get rid of this. And its propeller produces a thrust of blah, blah, blah. What is the lift to drag ratio of the airplane while cruising at altitude? Okay, so this is actually pretty easy, right? As far as the question is concerned, that's not a big issue. Because, you know, the lift is basically equal to the weight, and the drag is equal to the thrust because it's a Newton's first law problem. So not an extra difficult thing, but we want to have another guy here. And this is now a numerical problem, which means we shift modes, right? So we've done C mode, we've done A, we've done Q, and now we're going to do the numerical part. So then we have to come down here and do our EQN for the answer, which is the lift to drag ratio. Like I said, that's just the weight for the lift over the thrust, and that should give us a number. And we don't want any extra spaces here because WebAssign counts as extra spaces as though they're extra answers. So if you say, I want the students to get 4 points for this problem, and you have some extra space at the bottom, they might only be able to get 3.75 or something like that. So you don't want any extra spaces at the bottom of that. So let's see if that is a working problem. It feels like a working problem. I'm a little bit upset because I wanted to take a break. Symbolic formatting help. Uh-oh. I've got an error there. And I don't know what the error is. Oh, I didn't put section down here, did I? To put the section in both the question and the answer. And then it gives me what the lift to drag ratio is. That's too small. I don't like that. So make that a little bit smaller and make that a little bit larger. They go and weigh their own Cessnas and tell me that this is way too high. That's perfectly fine. All right, so 8.61, that's not really, that's a little bit low, but high enough to sort of give them the idea about what's going on. 9.48, that's close to what it should be, and so forth. Since this is not being used for something else, we could format this. WebAssign has a natural tolerance. You might have your own tolerance. So you could format this answer so that it hits your tolerance, right? So you could come in here if you wanted to and say, okay, I only want 2 decimal points afterwards. I don't want like 27. So you could do your integer part of this times 100 plus 0.5 to round upwards if it needs to round correctly, not upwards, and then divide by 100. And then you'll be fine. Now this is enough so that random errors in the math won't do anything weird, right? So this is really low, but it's still, rounding this up or down is much less than 1% or 2% or whatever WebAssign standard is. So that's perfectly fine. There's no need to have 7,000 digits of precision just because you can, because it's a computer. All right. So that seems to be sufficient. I think I've got the entire thing done, and I'll save it, even though I should have been saving it more often. Well, I did save it before, but I should save it more often. And so that's another one of these problems done. Now I'll hit through with 3 or 4 more of them and send them to the students when they get to school in January. Actually, they probably won't get to this until February, but they will get to it. So this is more or less how I do all of that programming there. I think that's pretty reasonable. I don't really plan on doing a bunch more of these, but if people want me to do them, just tell me, right? And I'll figure out more things to do. I won't do anything long like this. This is just to make sure that this is more or less me venting on how hard it is to do this, right? Or not hard, but how long it takes to do this. But if you want specific kinds of questions answered about how to program these things, I'll do my best, right? Obviously, you can email WebAssign. I did that for the algebraic problem part. I wanted to do it with symbolic stuff. I don't see why I can't, but the way it's programmed, you can't. So, the guy Brock at WebAssign, he was really helpful and it was really nice. So contacting them is a really good option. But if you'd like me to just do more examples, go ahead, leave comments, and I'll do more examples. But tell me what you want to do, and we'll try to make it more specific so we can, do it in 15 minutes instead of an hour and a half. Okay? Yeah, this was an hour and a half, but it took me literally all day to do the first template for this. Now, the next ones aren't going to be so long because I'll copy and paste, right? But, I wanted to go through this again. So even knowing exactly what I was going to do and having a previous one sitting there, it took an hour and a half. Part of that's the talking, but a lot of that's maybe about a third of it. But still, a lot of it is just going through and doing all the programming stuff. It takes a while to program these things. All right. So you have a good day. Let me know if you need any help or anything, and I will try to play around with these things if you like. Bye now.